so we talked about our properties of logarithms, and so what we want to do is we want to try our properties without using a calculator, and we want to see if they really do work for us. So it's telling us in this information that log of 2 is 0.3 and log of 450 is 2.65. So we want to find the log of 900. So you've got to decide how can you take 2 and 450 to get 900. Well, hopefully you recognize that that would be the same as taking the log of 2 and timesing it by 450. Now, using our big three properties of logarithms, we know if we have a multiplication inside the parentheses of the logarithm, what we really do is we take the log of the first number and add it to the log of the second. So log of 2 is 0.3. And log of 450 is 2.65. So if we take those, 0.3 plus 2.65, the log of 400 would have to be close to 3. Now they're rounding off there, but if you check it, and you'll notice I didn't read the mode there, it says set it as float again. So let's go back to float so that we can be right. That's going to be 2.95. So go back to your mode and reset that on float. That's usually where we keep it. Now just type in log of 450. I'm sorry, log of 900. And you should get about 2.95 when you round it off. Okay? So now we've got that. That's how we can apply our properties. So let's look at the next one. If log of 6 is 0.78 and log of 11 is 1.04, how can we find log of 66? So the first thing you're going to do is you're going to rewrite. You're going to rewrite 66 as a product of 6 and 11. So that will be log of 6 times 11. Now we're going to use our first property of logarithms, which is the product property, and we're going to rewrite this because we notice that we've got a product on the inside, so we're going to convert it to a sum or an addition on the outside. So we're going to have log of 6 plus log of 11. Log of 6 is 0.78. Log of 11 is 1.04. If I add those together, I get 1.82. And you can check that on your calculator to make sure it works. Now look at the next one. If we know that the log of 36 is 1.6 and the log of 3 is 0.5, then the log of 12 is what? How can we take 36 and 3 and get to 12? Well, I look and see that if I took 36 and divided it by 3, that would give me 12. And you'll notice here that now I've got a quotient inside my parentheses of my logarithm. So this is where my quotient property comes in. If I have a quotient on the inside, what I need to do is I need to subtract on the outside. So this will become the log of 36 minus the log of 3. And log of 36 is 1.6. The log of 3 is 0.5. If I subtract those, 1.6 minus 0.5 should give me 1.1. And so there I've used the quotient property to evaluate a logarithm. Now if you look at D, it says if log of 11 is 1.04, find log of 121. Well, how do we get 121 from 11? Hopefully you recognize that 121 is 11 squared. So I could write that as 11 squared. Now I can use my power rule, which says if I have a power, I take the power and I multiply it by logarithm of the number. Well, log of 11 is 1.04, so I'm going to do 2 times 1.04, which is going to give me 2.08. And you could check that on your calculator, log of 121. It doesn't come out exactly because we are rounding off here, but we do get 2.0827. So we get something that's very, very close. So these properties of logarithms can be used in this way to be able to rewrite a product or a quotient in terms of that, or we can rewrite them as a single expression. So in these next group of examples, when it says rewrite as a single expression, sometimes you will hear me say condense. When we're condensing, we want to put it back together as a single logarithm. So now what we want to do is notice what sign is here. If there is a plus sign between two logarithms, what we do is we keep the logarithm, but in parentheses, if there's a plus on the outside, we're going to have to put a times on the inside. And so log of 2 times 5 becomes log of 10. And we can evaluate log of 10. Log of 10 is 1. You can do that, check it on your calculator. So if we want to combine these, log of 500 minus log of 5, we're going to look at the sign that's between the two logarithms. A minus sign on the outside tells us that we're going to have a quotient on the inside. So this should really be written as log of 500 divided by 5. 500 divided by 5 we can simplify that down to log of 100. Log of 100 is going to come out to be a nice pretty number, and that's going to be 2. Okay, same thing for our next one. Now this time it's not a common log, so we won't be able to check it on our calculator, but we can still use the properties no matter what the base of the logarithm is. If we have a minus sign in between two separate logarithms, we keep the logarithm and its base, and a minus on the outside changes to a quotient on the inside. The first one always goes on the top, the second one goes on the bottom. So that becomes log base 5 of x divided by 10. I can't actually divide x by 10 because I don't know what x is, so there's really nothing else I can do to that problem. I can't simplify it any further. So now I'm going to look here. Now a lot of times students will see this plus on the inside and think that they need to change that to multiplication. No, the rule is that the plus has to be on the outside and you put a times on the inside. If there is a plus on the inside, it just has to stay there. But what you'll notice that I see in this problem is I see a product. I see 2 times that number. Whenever I see 2 times something, that tells me that this number should be the power that's on our argument of our logarithm. So it's going to move up here. So this is going to be rewritten as log base 3 of x plus 1 squared. And you could square that out if you want to, x plus 1 times x plus 1, but I'm okay with you leaving it just like this. So now look at the next one. On the inside, I've got a multiplication, but I don't want to expand it out. I want to leave it like this. But I notice that there's a 3 in front, and a 3 multiplied in front means that that becomes the power. So this is going to become log of 2m to the 4th raised to the 3rd. Now, because these are all numbers in here and variables, and I want to raise to the 3rd power, I can use my rules for exponents, and I can go ahead and clean this up. I can cube the 2. 2 cubed is 2 times 2 times 2, which is 8. And raise a power to a power. I keep the base, and I multiply the exponents. So I end up getting log of 8m to the 12th power. Okay? The next thing that I need to do is look at the next type of problem. Here it wants you to simplify the expression. This uses our inverse properties. Notice if I have log base 5 of 5 to the 7th, same base, cancels and leaves you the exponent. So that will equal 7. Log base 6 of 6, those are going to cancel. Remember, the understood power is 1. There you go. If there's not a base, it's understood to be 10. Log base 10 cancel, leave you negative 4. Here I've got a plus sign on the outside, so I'm going to combine those to log base 12 of 3 times 4. That changes to a product on the inside, and that gives me log base 12 of 12. Those cancel, leaving you the understood power, which is 1. So we've gone through all of our properties of logarithms, and now what you're going to do is you're going to work on some practice using these properties. Okay? So use these as examples to help you.